If you've ever looked into pursuing a STEM field after graduating high school, you've probably already heard about a bunch of science or engineering fields, as well as some of the things someone in that career may do. For example, you probably picture bridges when you think of civil engineering, and things like gears or engines when you think of mechanical engineering. But what comes to mind when you hear chemical engineering? And what exactly separates a chemical engineer from a chemist? One of the best ways to illustrate the differences between chemists and chemical engineers is by looking at something familiar that involves both of them: the process of making ice cream. Have you ever gone down the frozen food aisle at your grocery store and wondered how a tub of ice cream gets there in the first place? It's easy to overlook all the effort and resources put into making ice cream. The process is longer and more complex than you may expect. So let's say you were tasked with making a new flavor of ice cream. Where would you start? Well, you would probably gather your necessary ingredients and try mixing them together in a bunch of combinations until the ice cream started to taste the way you wanted. At this point in the ice cream making process, you'd be doing the job of a chemist. Chemists are people who figure out how much of what ingredients you need to make a finished product. In this case, ice cream. When making ice cream, chemists need to find the right balance of ingredients such as sugar, which gives ice cream its sweet flavor, and milk, which gives ice cream its smooth texture. In addition, a chemist would also need to figure out how much flavor to add in order to create the different types of ice cream you see in the store, as well as what kinds of preservatives to keep your ice cream fresh. Once a chemist figures out the components that will go into your ice cream, usually done through many rounds of small-scale testing, you now have to figure out how to make this ice cream on a large scale. This is a crucial part of the process because even though making small batches of ice cream works for chemists in a lab, an ice cream company can't wait for its production to be made one bowl at a time. This is where chemical engineers come into play. As a chemical engineer, it is your job to take what chemists do on a small scale and move it up to a large-scale operation that may take place somewhere, such as a factory. At first, this may sound like an easy task, and you may even be thinking, well, if you want 1,000 times more ice cream, just multiply every ingredient by 1,000. Unfortunately, it's not that easy because if it were, we would just be chefs who really like math and science. You see, in the real world, the same reaction or process may not be carried out the same way on a large scale as it is on a small scale. But no need to worry, since as a chemical engineer, you have a robust tool belt and understanding of math, physics, chemistry, and engineering to help you along the way in addressing these types of problems. As a chemical engineer, there are several variables you'll need to consider and adjust in your process to effectively make your ice cream. Some of these variables may include figuring out the size and type of mixing vessel to use, how to add your ingredients to the mixing vessel, adjusting the temperature and pressure of your ice cream, and minimizing how much energy is required for your process. So when making ice cream on a large scale, you may find yourself asking the following questions. Is it best to mix the ingredients in a giant mixing container, or in a long pipe where ingredients will flow through and mix together themselves? How should I add in the ingredients? Should I pump them all in at once from the top of the vessel, or should I bring them in along the sides of the container to make them combine in a circle, like a whirlpool? At what temperature and pressure should I maintain my mixture? Is it better to mix the ice cream when it's liquefied, or when it has a thicker consistency? What if I don't add the sugar until the very end? Would this require less energy? All of these maybes and what-ifs are just some of the questions that a chemical engineer in charge of designing an ice cream making process would seek to answer. In addition, as a chemical engineer dealing with large-scale production of a product, you will also hear throughout your education and career what's called the triple bottom line. The triple bottom line is the idea that engineers should design and optimize their processes so that it benefits the people, in this case ice cream lovers, the planet, and profit. After all, how good can a process be if it doesn't create something that people like, if it harms the environment, and if it doesn't generate any money for a company? Manufacturing ice cream is just the tip of the iceberg when it comes to what someone with a chemical engineering degree might do. Chemical engineers can also serve vital roles in areas such as the production of energy, food and drink, medicine, paint and protective coatings, plastics, and many more. As you can hopefully tell, a degree in chemical engineering opens up a wide variety of exhilarating and exciting job opportunities and is worth a deeper look. Not to mention, it is one of the highest paid engineering disciplines you can choose to pursue. If you are interested in learning more about chemical engineering or what other sorts of things chemical engineers do, we posted a few extra resources in the description for you to use as a guide.